Right. Hello, everyone. Welcome to 345 Tech Talks. I'm Andrew. I'm with my colleague Danny, and we're going to talk about automating monitoring and control systems. So, one of the examples we gave in last week's podcast was where you might be monitoring the temperatures. Let's say a supermarket chain that's monitoring the temperatures in its fridges and freezers. And in the old school way of doing that would be that someone would literally have to go around several times a day with a pad and write them into a form, and then they go in a folder that goes on the
Dreaded
shelf.
form.
That goes on a shelf somewhere, and never to be seen again. And in the modern world, what you want to do is you want to automate that. So you'd want to automate that from the perspective of gathering that, you wouldn't want to be paying someone to walk around, 2 aisles of fridges in the supermarket so many times per day, writing stuff in a book. You wouldn't want to, if you wanted to actually get that data usefully, you wouldn't want to be paying someone to rekey it. And if you needed to do some analysis of it, you wouldn't then be expecting someone to be loading that into Excel and manipulating it. You want the analysis automated. So we're kind of looking at that as a problem space.
Yeah.
Obviously, as you know from last week, we've been making an effort. So we've got different but still equally glorious shirts on today. What's your one, Denny?
This is just a summer number that's taking me back to, well, not summer of 2020 for obvious reasons, but from previous
to a
years.
good summer.
To a good summer, yeah.
So
What is yours? Is yours a?
Mine's a long sleeve.
Oh, okay,
But
yeah.
it's Italian. It's a Montesini. So not quite as expensive as last week's Claudio Lugli, but it's still a nice Italian
number.
shirt. So
very nice.
So that's what I'm going with this week.
Yeah.
So where do we start then, Denny?
I think so. Firstly, it's a really interesting subject because I think the automation is huge, and trying to automate processes, certainly in somewhere like a supermarket, is really important. But just starting off as to why these supermarkets would firstly have these types of sensors in a, let's say, a fridge for a minute. That also equally works for some of the heated counters that a lot of supermarkets have now as well. So, but let's start with obviously the fridge side, because I think it's quite it's relatable.
But it's relatable to lots of things, isn't it? Because things that have to be kept at a certain temperature, which could be a piece of manufacturing equipment. You could have a furnace or an autoclave in your manufacturing plant need to be kept at the same temperature. You could have something in pharmaceuticals that needed to be a controlled environment. So it's actually really applicable in a lot of places. But everyone knows what a fridge is. Everyone's been in the supermarket and everyone knows what a fridge is, which is kind of why we're picking on this. So and obviously if the fridge is at the wrong temperature, food can spoil. And which means that what you want to avoid is not knowing there's a problem, finding you've got to throw away a load of food, or finding that someone goes home with some food that's actually bad because you haven't done that.
Yeah.
So so where do we start?
I would like to start with, what does it look like? What does it look like inside these inside a supermarket chain? And then what I also want to see is what it looks like inside the cloud. So, and then how we bring those two to join in the middle and talk, and have that automated process that we obviously started off with at the top.
So that is a great kind of angle on this. So obviously, you can have a device which is effectively some sort of temperature probe that goes in the fridge. It's really how that's connected up, and usually there's a couple of different ways that that's done. So sometimes you can get devices. Some of the devices you get, you install them somewhere and they connect directly through Wi-Fi connection, or they might have a SIM card in them, and they connect over the 4G network, and they connect directly. So particularly if you were wanting to connect things that are in a lot of different places. So let's say, for example, you had a fleet of ice cream vans and they were all in different places. Then you'd put a sensor in each one that had a SIM card in it, and so that device would literally connect straight to the cloud by having a SIM card in it, and it used a mobile phone network, and it connects up. However, if you're in a building where there's a lot of these things together, what you might do is they might all be connected to a network, and then you'd have what's called an edge device in that supermarket. So an edge device is basically a PC that all those devices connect into, and then that PC is the thing that then connects over the internet, probably over the in this case over the supermarket's internet connection, and that would connect to the cloud where it transmitted the data. So you kind of got two models. Either you've got the device is itself connected, or you have a number of devices that connect into what's called an edge device, and that edge is the gateway to the cloud. So, typically speaking, if you've got a lot of sensors in the same building, you'd use an edge device. And if you've got if you've got small numbers of sensors, and particularly if they're mobile, then you'd kind of use the connected devices themselves. So that's kind of what the kit looks like. It's not much more complicated than you've got a sensor in each of your fridges in this case, and then you've got a PC somewhere with some software running on it that knows how to communicate to the cloud, and it knows how to communicate to those sensors. And that's basically what the supermarket side of it looks like.
Quite a fascinating part of that is the way that space has grown from a technology perspective. From the guys going in with, just say, like a probe that you should go in every couple of hours, for example, and going to make sure that the fridge is at a certain temperature, and if it isn't, then you have to go and adjust it. And even the step up from that is the sensor sits in the fridge and then alerts somebody to what that temperature may be. And now we're at a point where we can actually talk back. So we can actually talk back to that device and actually adjust that. So the way that space and that technology has grown over just a short period of time is phenomenal, isn't it?
Yeah, and I think that's one of the places where things get really interesting, is when you're able to send the control signals back. So, because most fridges have got like the little dial. You turn the dial and it goes. Usually, it has something meaningful, like 1 to 6, and then you set your fridge somewhere, but that dial is effectively how hard the compressor's working in the fridge that's driving the refrigerant through it. So ultimately, if you can have a device that not only measures the temperature, but is able to tweak the dial as to how hard you should be pumping the refrigerant through, or a thermostat, or setting the thermostat as to where, whether the fridge has reached the right temperature, then that's kind of a really good starting point, because that gives you the ability then to instead of just setting it and then hoping it's all right, you've got the ability to do something about it. So that's absolutely where we're looking to get to that, and it's the same with and it's the same with those other applications we sort of said, that if you're in manufacturing, you've got to keep the temperature in a furnace. Well, you can turn you can turn the gas up or down, and it will make the furnace burn hotter or less hot, but the fact that you're able to control it, I mean, it's in some ways, this is a little bit of a funny one, because obviously you can have control systems inside a plant that do that without needing to go to the cloud. However, in this example, and certainly in things like pharmaceutical manufacturing, you have to actually be auditing this stuff. And so the fact that you can have a control system making sure things are correct and the environment's consistent, it still needs to be audited, and it still needs to be measured. You still need to be able to go and prove over a period of time that you've had, that you've been within certain tolerances. And so it's still important that you can collect things, even though, yes, you can have a control system that does that.
That leads us quite nicely said around the auditing and having the ability to read the, I'll say, the data that comes out of it. So what does that look like? What does that look like in cloud form? We're big cloud advocates, obviously. What does that look like in cloud form, and how does that make life easier for end user? And then also, how does it make life easier to run, like you say, big audits for huge amounts of devices and machines?
So, well, there's a couple of ways we could answer this. One of them is that I mean, 345, we're a Microsoft Gold partner. So one of the things that we've been building this type of solution on is Azure Iot Hub, where you actually get a lot of things out of the box, because ultimately what that is all about APIs for a start, because your supermarket and all your sensors transmitting to the cloud, ultimately they're hitting an API. But in the world of these sort of connected devices, broadly termed under IoT, although as we discussed last week, a lot of people think that's like your smart fridge, whereas actually we're talking about commercial applications where you've got sensors and connected devices. It's still the same technology. It's just that we're a bit more tangible about what it is. So you're hitting an API, and then ultimately there's that can also, the other thing about things like IoT Hub is you register the devices. It knows about the devices that it's connected to, and it's able to then send updates to them and send signals to them. So it gives you something that not only receives the data, but you can then poke it back to say, send this message back to the device. And an IoT Hub is kind of a cloud product that allows you to do that. But ultimately, it's all around. It's all built around APIs. But so anyway, they've got these devices. They're transmitting data, and that's all great. And they're hitting this API. Now, what you want to do then is what we'd normally do is we get those into some kind of what we now call a streaming technology. So in Azure, you might use Azure Service Bus. If you're open source, you might use Apache Kafka. But you'd be looking at putting them in a stream, and a stream is, for those of you who don't use them, it's like a queue. In the old days, you put them in a message queue. The difference between a message queue and a stream is that a stream can have multiple readers, whereas a message queue generally you put messages in one end and something reads them off the other. Whereas the whole point of having a stream is that you can have as many. Once you're writing into a stream, you can have as many different systems reading from it as you need. And that's really important in a system like this, because what generally we're looking at with this data is you're taking two views of the data. So you're taking there's the short-term view. Is this stuff what's happening right now? And that's your short-term view of the data. And then you've also got the longer-term view, which is, what are the trends over the last month? What are the trends over the last year? How many times over the last year have I been doing this? What are the statistical measures? What's the standard deviation? What's the blah blah, all that kind of stuff. So you kind of got your historical data, and then you've got your what's happening right now. And those, and if you wanted to write a solution, you treat each of those quite differently. So the fact that you've got a stream means that you can have a let's analyze the stuff in real time, and then you can have a let's store that data for analysis later, and you get basically two sets of readings off that same stream. And so the offline stuff, the historical stuff, is a bit easier to do. You probably just put all that in a data lake, and then you'd use something like you'd use some kind of analytics, some kind of data lake analytics to then go and crunch those numbers and present it to a dashboard where you could look at it and read it. And that's your historical side of it. So you might, depending on what you want to do, you might be using something like Azure Synapse Analytics, or you might be using something like Databricks, or those kind of big data tools to your data lake. And then you could use something like Power BI or Tableau to produce your dashboards, and that's presenting your historical data. What's happening in real time is actually a lot more interesting, because you're wanting to really have things that are processing each message that comes in and compare that. And so there's a different set of tooling for that. Again, some of that's in Databricks. So again, I don't know how many people are familiar with the term of streaming analytics, but streaming analytics generally means you're doing analytics on data that's coming in real time, as opposed to historical, as opposed to the offline analytics, which is crunching data sets that are already there, and so you have all sorts of different possibilities then in what you're doing with the streaming analytics. You could be taking averages of the last minute. You could be putting that data through a machine learning model and using that to make predictions about whether things are good or bad. You could be putting that through some kind of alerting model, setting threshold alerts, and there's all kind. There's a whole load. The whole world of alerting isn't itself really sophisticated, because you sort of think, well, if you get one random reading, then do you alert on that, or do you wait until you've got 2 in a row, or do you wait until you've got 10, or do you wait until the average of them over the last 10 seconds is more than this? Or how do you because a lot of things you get when you're dealing with measurements in the real world, you tend to get noise, you tend to get variation in the readings, and so you kind of got to think, well, what are the actual, how do I know if I get one data point, is that does that count, or do I need to get more? So so anyway, the world of streaming analytics then. So certainly for us, we're again, most of what we do is on the Azure platform, and we'd probably go with Databricks. Now, Databricks is a standalone product, which kind of wraps around Apache Spark, but Azure do their own hosted version of it, which makes it kind of really easy to provision and easy to use, because it's just all built into your cloud system. But so it goes something like that. So offline analytics, data lake, and then some big number crunching, and then the streaming analytics, we'll be putting it through something like Databricks, and then possibly through some sort of machine learning, and then going from there. So that's kind of what the cloud thing would sort of look like. Does that kind of make sense?
Yeah, it was. You actually made a little point at the end there around the machine learning side, which is we've got a podcast on that actually. If you check out our Tech Talk podcast, and we've also got a really good podcast around data lakes. So we mentioned data lakes there from the number crunching and some storage. So we got some podcasts around that. So yeah, no, really interesting stuff. Really interesting. And I think you also mentioned we mentioned it at the start that these processes are very familiar across a lot of different industries, which is, I think, really important. We're obviously using one example today from an explanation perspective, just to try and understand how it works from the front to the back, so to speak. So, but it's really interesting to actually, we could probably talk about this for quite a while, based around different industries, like you said there, the manufacturing industry and machines and things like that. So yeah, really cool, really interesting stuff. Thank you.
Yeah, no, so one of the other things I didn't actually quite pick up on is the fact that if you've got your IoT hub and you're receiving messages, you could be receiving those messages in from like say, if in the case of a supermarket might have 500 stores in the UK, and then there may be an average of, I don't know, 50 fridges in each one of those, and then they might be sampling data every at least every second, sometimes every 100 times a second. So you actually, one of the things that so there's a couple of things in here. One of them is that when you're in scenarios like this, the sheer volume of that data is just vast. It's not like just like, oh, here's a message, and then oh, well, there's another one. Oh, wonder if another one will come to. It's not that kind of thing. It's just this stuff comes thick and fast. There's just reams of it, constant. It's like it's like data coming through a fire hose. in fact, AWS have one of their products named like Firehose. Is it Firehose Kinesis? Kinesis Firehose, because it's a really good analogy that this data comes through so fast. It's like it's come through a fire hose. It's really being sprayed through really fast, but also it might be all jumbled up. So when stuff comes through, it's like, which store is it? Which fridge is it? And so that's where the streaming analytics kind of needs to unpick that, because it needs to not only know that I've got a load of readings, but it needs to segregate them by store and then by whatever the thing is, the fridge, freezer, the furnace, whatever it is that I'm measuring. So it needs to actually segregate those out and then accumulate those, and that's why you need some quite sophisticated kit to be able to be doing that sort of thing in real time. And that's where the likes of Apache Spark is a really good sort of fundamental technology, because one of the things Apache Spark does is it does the analytics, but it does it on data that's in memory, and so you're pushing this stuff through and it's in memory, and gradually the older stuff gets flushed out of memory and the new stuff comes in. But you've got all these data sets in memory in a cluster, and it allows you to do that analytics in that sort of real time, but on quite big data sets that are coming through really fast. But you can then segregate it and analyze it and crunch it in real time, and so it's amazingly powerful. And and that stuff's just there now. You can go, you can provision it in the cloud. Obviously, these tools are available in AWS and they're available in Azure and all that sort of stuff. But it's available it's available in the cloud, and you can. The amazing thing about where we are in the world of technology now is that you could have that in 15 minutes time, or even 5 minutes time, whereas going back a while, even 10 years ago, cloud was really early in its infancy, and if you wanted to have built a cluster that did that sort of stuff, it would have taken you a long time, and you'd have had to have teams of infrastructure people that are actually just building these servers and installing things on them and hooking them together and configuring them. It would have taken ages to have that kind of processing power, that kind of number crunching power. Would have taken a lot of time and a lot of expense and a lot of expertise to put together. And now you can just say, oh yeah, I want a Databricks.
Yeah.
Oh, I've got one now. Yeah. It's absolutely mind-boggling that you can just get one of these. You can just get one of these cloud products that under the bonnet is provisioning potentially hundreds of servers under it, and it just manages as one thing, and it just works. You just ask for it, it gets delivered, and it's just there. And so that is just I think that's something that is it's almost like really hard to get your head around, just how much power is available at your fingertips in just a couple of minutes.
I think I saw I saw an interview with someone this week around technology, and I think it was something along the lines of only 20% of some of the things that are available in around the tech space are actually being utilized. There's so much there that people aren't fully aware of, like you just said there, having it accessible and in pretty much all cloud space now, whether it's like we say Azure, whether you're in Google,
and people stick with what they know, don't they? I mean, it's a natural thing, is that the technology moves fast. Generally, the technology moves faster than our collective ability to learn it all. And so that's why you get this kind of, the stuff that's been around for a long time. A lot of people know it and they're comfortable with it. I mean, in the world, I know we're getting slightly off topic here, but in the world of cloud, for example, there are, most people that are using the cloud have got virtual machines being hosted for them. They've just done a lift and shift. They've put stuff in virtual machines, and that's great. That's a great start to your cloud journey, but it's not using all these, all these tools. All you've done is you've got rid of the problem of having to buy your own servers. But if you do that, you still need to manage them, and you still need to have people look after them. You still need to patch them and make sure they've got the latest virus scans and all that sort of stuff. so it's great to do that as a first step, but that is what most people that are using the cloud are using that, and then they might be using Office 365 or something like that, and that's where the vast majority is. So this sort of stuff about the more rarefied end of sort of the really powerful data platforms, not as many people are using them, but maybe that's because they still think that the barrier to entry is so high. Because, like I say, if you wanted to build a really big data platform 10, 15 years ago, the entry level might have been, £1 million, and now the entry level is like zero.
That's crazy.
That's how crazy it is. But in people's minds, it's kind of that might be where they're still that might be where their head still is. So
potentially an education point.
Yeah, well, that is why we do these podcasts, Danny.
Yeah, that's it. That's what we're here for.
If only more people watch them, then then everything will be okay.
It's that I think that'd be quite a nice podcast actually, just around that developing that development around cloud and the changes, because again, there's still huge amounts of business that aren't maybe trusting cloud. I think there's a lot of it. I think it's security. I think there are parts of cloud that people absolutely love and adore, but there's that security side, I think, is where I know IBM Cloud have seen some challenges. So that may be a podcast in itself.
Yeah, and it's like I say, there's always the. I mean, I think the number of people that have got cloud fear are probably getting smaller and smaller. And I think some people use that, quite frankly, people use that as an excuse to not have to do all the things that they really should be doing. But let's get on to that another one. So
that's a good subject for another day. Absolutely,
that's a good one for another day. So I think we've waffled on long enough for one time. So thanks a lot for listening, everyone. We've talked about big data platforms that taking reams of measurements from a supermarket's fridges, and I hope you enjoyed it, and we'll catch you next time. So it's goodbye from me, and it's goodbye from Danny.
cheers guys.
Right,
Take care.
Catch you later.